Hi students. So here we are going to see about a Pythagoras property and the relations between its right angle triangle. So right angle triangle and Pythagoras property. So here I consider one right angle triangle ABC, right angled at B, and the side which is opposite to the right angle is called as hypotenuse. Hypotenuse, hypotenuse. So Pythagoras says that in right angle triangle, side opposite to right angle is called hypotenuse. So here first we are naming this side is a hypotenuse. So here the Pythagoras property says that in a right angle triangle, the square of hypotenuse is equal to sum of square on the legs. The square of hypotenuse. So we have to know which side is this hypotenuse. Hypotenuse is the side which is opposite to the 90 degree. So if you made the square of this side, it will be equal to sum of square of the on the legs. So these are the two legs of this hypotenuse, right? So if you add and square and if you add these two sides, we will be getting a Pythagoras property. So for example, its hypotenuse is given as an AC. So if we square the AC's hypotenuse, we will getting sum. We have to add the square of the legs. Here the two legs AB and BC. That's square, right? So AB square plus BC square. We have to add the square. This is what Pythagoras theorem says. But we cannot say this as the formula, since the triangle names will be changed according to the problem, like ABC, PQ, L, M, N. So just remember these things. The square of hypotenuse is equal to sum of square on the legs. So if you find a hypotenuse side, then we can find a rest two sides. Clear? And next, if Pythagoras property holds, then triangle must be right angled. So if it satisfies this condition, then we can say that given triangles are right angled. So here we go for the problem. PQR is a triangle right angle at P. So soon we have to draw the triangle, then only we can identify which side is the hypotenuse. Okay, so it is PQR and right angled at the P. So this right angle at P, and we can call this in a Q and R. It is given if PQ is 10 centimeter, PQ is given as a 10 centimeter, and PR is given as a 24 centimeter, and QR is what we have to find, right? So here we can apply the Pythagoras property. So wide by property, sometimes it will be called as theorem also. So in higher classes we call it as a theorem, now we have to call it as a property. So we have to find which is hypotenuse, right? So side opposite to 90 degrees is the hypotenuse. So this side will be the hypotenuse. So square of the hypotenuse. So hypotenuse square we named as a QR. So QR square is equal to, and rest we have to square and add. Rest is the PR and PQ. So square it and add. That's it. So QR square we have to find, right? So PR is the 24. So 24 square plus PQ is the 10 square. Square means nothing, just we have to multiply with itself, number with itself. So QR square is 24 square means nothing, we have to multiply 24 with itself. 24 into 24, we will be getting it as a 576. So 576 plus 10 square is a 100, right? 10 into 10 is 100, right? So it is a square, we have to write in the power. So QR square is equal to 576 plus 100 is a 676. So then, so QR, so this is a QR. Actually we need only the QR, right? It is in the square. So as well as how we multiplied and we find the same thing we have to find for this also. So 677 we have to find the number which multiple by itself will be getting a 675. We will be getting as a 26 into 26, right? So we have to multiply the two numbers, the both also have to same, and we have to get this. So 26 into 26. So QR square is equal to 26 into 26. Then QR is equal to, square means the two times, the number multiplied by itself one more time, right? So if you are removing the square, it will be getting it as a ones. Actually in the higher classes we will be learning it as a square and square roots. Now just remember it as a square, we have to multiply the number by itself, and while taking it to remove the square also, we have to remove one of it. Clear? So example, I can show that for square and square root, 3 square means we can say 9. The 9 we can represent into 3 into 3. So if you are asking a square root, we can represent into 3. So here we go for the next problem. A 15-meter long ladder reached a window and 12-meter high from the ground on placing it against the wall. So long ladder is placing it against the wall. So this will be the ground and this will be the wall. Find the distance of the foot of the ladder from the wall. So this distance of the foot of the ladder from the wall. So this distance A we have to find. So there's no name. Let me name it as an P, Q, R, and where there will be a 90 degree between the wall and the ground, right? So in between the wall and the ground always it is 90 degree, no slanting wall there, right? So now we can apply the Pythagoras property and we can find, right? So by Pythagoras property we can say that this is the hypotenuse opposite to 90 degrees. So PR square is equal to PQ square plus QR square. So PR square is a 15 square is equal to PQ is a 12 square plus QR is a, we don't know, that we have to find, it is given as a A. So let it be a square. So 15 square we can say it as a 225. 15 square means 15 into 15 is a 225. 12 square is a 12 into 12 is 144 plus A square. So let me rewrite. So A square plus 144 is equal to 225. So let me bring here, it will become as a fraction. So A square is equal to 225 minus 144. So 225 minus 144 will be getting it as an 81. So A square. So A 81 we can write as a 9 into 9 to both the same number. So A square is a 9 into 9, then A is equal to 9. Then we have to write it the unit 9 meter, right? So remember that square means we have to multiply by itself 15 into 15. While taking the square root, we have to represent it the two equal number multiplying it, and we can remove one of it. So therefore distance of the foot of the ladder from the wall is 9 meter. Clear? So here we go for the next problem. Which of the following can be a side of a right angle? So given the three things, we have to find which is the right angle. So here there is no triangle and no 90 degrees given. We have to find whether it forms right angle or not. So first we need a hypotenuse to check whether it's satisfying a Pythagoras theorem or not. So we don't know which side will be the hypotenuse. So let us consider greater side. Consider the larger side be the hypotenuse, right? So here which is the larger? 6.5. So if you square the 6.5, it have to be equal to square of this two side, right? So if you square the 6.5 means 6.5 into 6.5. Clear? So 6.65 into 65 we will be getting a 4225 and 2 decimal is there, so we will be keeping it as a 42.25, right? So next thing we have to square and we have to add this. So 2.5 the whole square plus 6 square. 2.5 whole square means 2.5 into 2.5, that means 25 into 25 we will be getting as a 625 and 2 decimal point we will be getting as a 6.25 plus 6 square is 36. 6 6 are 36. So if you add this, we will be getting the no decimal here, so decimal will be 65, sorry 25, and here 6 plus 36 we will be getting as a 42. So hence this both got equal, right? So one of the square is equal to sum of the square of other two sides. So it satisfies the Pythagoras theorem. So therefore given sides are of the right angled triangle. So always try with the larger side as the hypotenuse we will be getting, and also the hypotenuse will be always larger in the right triangle. That's why if it is not equal, then sure we will be not getting if you choose any other side as the hypotenuse also. Clear? So here we go for the next problem. A diagonal of a rhombus measures 16 centimeter and 30 centimeter. Find its perimeter. So diagonal of the rhombus is given, but we have to find the perimeter. Perimeter means we need the sides of the rhombus, right? So let's check. So diagonal is given. Let me name it as an A, B, C, D, and intersecting point as O. And very interesting problem is this. So it is given this, let me consider this as an 16 centimeter and this AC as a 30 centimeter. And we know that the intersecting point always got a perpendicular and all the sides are equal in rhombus, right? All the sides are equal in a rhombus, and also diagonal bisect at right angle, right? So diagonal bisects at right. Bisect means it cut into two equal parts and also in the right angle. So the diagonal, the AC will be, this OA will be equal to OC, which will be equal to half of the 30, right? So half of the 30 is a 15 centimeter, the same. So DO and OB will be equal, and which is half of the 16. Since it bisect, it will be equal half, right? So we will be getting an 18 centimeter. So now it forms a right triangle, right? You can check this AOB is a right triangle, and we know that this is an OA is a 15 and this as an 8, and we can find this hypotenuse, which is, we call it as an sides of the rhombus. Then we can find the perimeter, right? So by in triangle AOB, Pythagoras property, or sometimes we call it as a theorem, this is the hypotenuse side, right? So AB square is equal to AO square plus OB square. So AB square we don't know, so AO we know it as an 15 square plus, and OB we know it as a 8 square. So AB square is equal to 15 is a 225 plus 8 is a 64. So AB square is equal to 289. So 289 we can write it as a 17 into 17, right? So then AB square is equal to 17 into 17. So AB is equal to 17 centimeter. So we have found one of the side as a 17 centimeter, and we know that all sides are equal in rhombus. So all sides are 17 centimeter. So what will be the perimeter? 17 plus 17 plus 17 plus 17, right? 4 into 17. Perimeter of rhombus is equal to 4 into sides, since all are equal. So 4 into 17 is equal to 68 centimeter. So therefore perimeter of rhombus is 68 centimeter. So just note it that that all the sides are equal in rhombus and diagonal bisect at right angle. So it bisect means cut equal parts and also in the right angle. So like that, square and rectangle also have a right angle at each corner, and each vertex, 4 vertices will be having at the right angle, right? So those problem also we can use the Pythagoras property. Thank you.